Hi, welcome to my channel Study to Success. In this video, I am going to talk about Ohm's law, series and parallel resistance. So let's get started. Ohm's law. According to Ohm's law, current is directly proportional to voltage and current is inversely proportional to resistance. So both the expressions have I, so I can combine them together as single expression. We have I is proportional to V over R. If you take 1 over R as a proportionality constant, we have I is equal to V over R. And this is Ohm's law. Now, let us look at plotting the graph of V versus I. Since voltage is directly proportional to current, meaning as the voltage increases, the current increases. So when we plot the graph, it is going to be a linear graph like this. So the linear graph, what we have got, you take the slope. Slope is nothing but rise over run at any 2 points. So if this is rise and this is run, so rise is going to be delta V. Run is going to be delta I. So delta V over delta I gives you the resistance R. In other words, I can write this as V1 and this is V2. And here it will be I1, I2. So delta V is nothing but V2 minus V1. This length we need, isn't it? Divided by I2 minus I1. This will be the resistance R. And always remember the unit of current is amps. Unit of voltage is volts. Right. Now let us look at series resistance and parallel resistance. Series resistance. For that, we need to consider two resistors. You can consider even three as well, but I want to take only two resistors over here. They are connected in series. Across the DC supply. So this is V, R1, R2. Always in series, the voltage gets distributed or divided, whereas the current will be the same. From the circuit diagram, we can write V equal to V1 plus V2, because if this is the total voltage, you can see that it is divided into V1 and V2. So I have taken that in one single expression where we have V equal to V1 plus V2 and call this to be equation number 1. From Ohm's law, we know I is equal to V over R, or we can say V is equal to IR. Now, if you take a look at the circuit, we can see that the current that is passing through R1 and R2 is I, whereas the voltages are V1 and V2 respectively. So using that in this expression, we can write V1 is equal to I times R1. Similarly, we have V2 is equal to I times R2. So all these I label it as equation 2. And now substituting 2 into 1. So we substitute in place of V as IR, V1 as I1R, and V2 as I2R. Oh no, it is I times R1 and I times R2. And we take I as a common factor and then write this as R1 plus R2. Since I appears on both the sides, we can cancel this now. And hence we have R equivalent for series circuit as R1 plus R2. This will be the final expression for a series circuit. All right, now let us look at parallel circuit. Parallel resistance, we have two resistors, R1 and R2, which has common start and common end terminals. That is parallel connection. And we have the power supply V connected across them. This is V, R1, R2. And this will be, the voltage will be same in case of parallel circuit. It's the current that gets distributed. So I gets divided as I1 and I2. We have I is equal to I1 plus I2. And I will label this as equation 1. From Ohm's law, V is equal to IR, or we can say I is equal to V over R. And if you look at this circuit diagram, you can see that I1 is equal to V over R1 because voltage is the same. I2 is equal to V over R2. So all these are expression number 2. So substituting 2 into 1, we get V over R is equal to V over R1 plus V over R2, or V over R is equal to V, if you take common, we get 1 over R1 plus 1 over R2. V and V gets cancelled, Hence, we have 1 over R equal to 1 over R1 plus 1 over R2. So this will be 1 over R equivalent. This is the expression for parallel resistors. All right, we have come to the end of this video. Hope you liked my video. If you like my video, don't forget to press the like button, share the video with your friends, and don't forget to subscribe and press the bell icon. So whenever I upload any new videos, you will get notified. Thank you for watching.